is a moving object? Any moving object, as you learned, has kinetic energy. That depends on the speed of the object. So if this ball has kinetic energy and energy is being conserved, why does it stop?
We learned that a moving object has kinetic energy, so what happens to the kinetic energy when the ball stops?
Well, I can answer that question for you. As the ball rolls, the air resistance and friction slows the ball down, converting the kinetic energy into heat. In other words, thermal energy. And if you feel the ball, you'll see that it's a little bit warm, and that's because the kinetic energy was converted into thermal energy, and thus the conservation of energy still applies. The kinetic energy got converted into thermal energy. To simplify things, scientists like to assume that friction is negligible, meaning you completely pretend like friction does not exist when we solve our problems. Does this mean that a rolling ball will always reach the top of the hill because it will not stop without friction?
I totally get it. I know what will happen. The ball will go to the top because kinetic energy will be conserved.
Not quite. Kinetic energy, once on the hill, will convert to potential energy as the height increases. Thus, kinetic energy will be converted to gravitational potential energy, so the kinetic energy actually decreases.
So the ball will never reach the top of the hill.
Whether the ball will reach the top of the hill or not will depend on the initial speed of the ball. If it has enough kinetic energy, it will reach the top of the hill. If it's too slow and it doesn't have enough kinetic energy, it won't reach the top of the hill. Another point to remember is that the initial kinetic energy will entirely convert to mgh at the highest point. At the highest point, the speed will be zero, and therefore the kinetic energy is zero. And since energy cannot be destroyed, we have to assume that it converted entirely to potential energy. Now let's look at a scenario where the ball will start at the top of the hill with the initial speed of zero. Here is the ultimate challenging question for today. If the height of the hill is 20 meters and the speed of the ball is 0 at the top of the hill, what will the speed of the ball be at 10 meters as it is? The total energy of the ball is mg times 20. Why mg times 20? Because the formula for potential energy is mgh, and the maximum height of the ball was at 20 meters. So we plug in 20 into the h. Now, the total energy is mg20 because the kinetic energy is 0. Okay, so if you add the mg20 to the 0, you still get mg20, and that's the total energy. Okay, the total energy will not change as the ball rolls down. The potential energy will decrease as the height decreases, and the kinetic energy will increase. So it'll speed up as the ball rolls down. The total energy, once again, will always remain the same. So you set mg20 equal to mg10 plus 1/2 mv squared. So the combination of the potential energy at 10 meters combined with the kinetic energy will remain mg20. If you rewind the video a little bit, you'll notice that the variable m can be divided on both sides of the equal sign, and you can cancel it out. So this is what I mean. If you forgot what m was, m represented the mass, but the fact that the m canceled means that the speed and the height relationship is independent of the mass. So the relationship between the height and the speed will remain the same regardless of how heavy the object is. But on a side note, do you remember what g is? G is approximately 10 meters per second squared, and it represents the gravitational acceleration. Now we're going to plug in the 10 into the equation that we have, hoping that it'll start making sense for us. Once we multiply the 10 and the 20, we get 200, and if we multiply the 10 and the 10, we're going to get 100. Then we're going to subtract 100 on both sides because our goal is to get the speed. Okay, our speed is v, and we need to get v alone on one side, so we subtract the 100 on both sides of the equal sign. And if we want to eliminate the 1/2, we just need to multiply by 2 on both sides, and we're going to get 200 on the left, and 1/2 and 2 cancel out, and you get 1 times v squared. 100 times 2 gives you 200, so you end up with 200 equals v squared. Then we're going to square root both sides in order to get v, okay? And v is the speed, and that will give us the answer to what the speed is at 10 meters.